Let me show you how to set your scope up to measure high-speed CAN bus circuits. To start out with, we're going to be doing our testing from the DLC. This is a little bit older vehicle. On your newer vehicles, you may not be able to do this test from the OBD port. You may have to back probe a module on the CAN bus or an inline connector. So for the CAN high circuit, we're just going to hook our lead up to that terminal, and I'm going to use terminal 4 for the ground side of it, and I'm going to connect that to channel number 1. For the CAN low circuit, we're going to connect that one to terminal 14, and we're going to use the same ground. We're just going to stack them together just like this. It's always important with most oscilloscopes that you use the same ground so you don't damage your scope or the component you're testing. And from that point, that is all of your physical connections made. So now we just need to set the oscilloscope up. So on the scope itself, we're going to set channels 1 and 2 up the exact same way. So I'm going to set them up, obviously DC coupling. We want to measure voltage, and for now we'll leave it on a full bandwidth. So exact same settings for channel number 2, and we're going to leave both of these on a 1 volt vertical scale for now. For the time-based setting, that really depends on what you're looking for. If you're looking for an intermittent concern over a long period of time, obviously you want it to be a longer time base. But for right now, we're just going to set it on 10 microseconds. So this is what we have at this point. A few things that we can do to help see it a little bit better and make sure it doesn't get distorted is, for one, we need to change our trigger setting right here. So right now it's set up to trigger on channel number 1. We just want to slide this up to about around 3 volts. And that'll kind of help keep the waveform right here in the center instead of it just scrolling by. The other setting we can make is go to each channel and put a low pass filter on. Now, on a lot of circuits, I usually use a 30 kilohertz low pass filter. But if we turn that on this circuit, this is what happens. We can't really do much with that. It doesn't look that great. So let me show you how to fix this. You just got to go back to your bandwidth filter, and instead of 30 kilohertz, we're just going to scroll it over to about 10 megahertz. And we'll do the same thing for channel 2. That should give us back our nice clean looking waveform. We have something we can work with as far as looking for irregularities in the waveform. So they should mirror themselves if everything is working correctly. If you want more content like this, then let me know in the comments. And if you found this helpful or interesting, then follow me for more.